Hey everybody, I'm Jason, and this is Jay's Project Garage. So it's about 7 o'clock or so Saturday morning. I've been up for a little bit. I've actually been up since about 4. I haven't really been sleeping very well lately for some reason, but I mean, I'm just getting old. Shut up. Don't even say it. So in this video, we're going to dive more into the Ford 302 and the 351. I keep kind of seeing the same recurring thing on Facebook, and I used to see it all the time on the forums. You get guys that jump on there and they keep asking the same questions over and over again, and they'll get a million different answers. I'm not the end-all be-all. I don't know everything, but I've been racing these things and building them for years and years. And I've educated myself. I've read every book and everything I can get my hands on. So hopefully I can kind of dispel some of the myths, rumors, and half-truths. Some of this is educated opinion and some of it's fact, but I don't know. We'll give it a shot. So let's get to the lame action. Myth number 1. The Mexican 302 block is way better than anything that was made in the United States. So the myth is that these blocks from Mexico have high nickel content and they're better iron, and that's actually 100% false. The blocks cast in Mexico were made from iron sourced from South America, which is actually a lower quality than the iron ore sourced in North America that was used in our blocks. So the iron used in the Mexican block is actually less wear resistant and softer than iron that we had, which I guess would be good for a racing application. The block has a little more give to it and can absorb a little more harmonics than the iron sourced here. Ford never put a whole bunch of nickel in any of their cast iron. The only benefit would be to soften the iron and to make it more corrosion resistant. There is nickel in cast iron, but it's like 0.15% or less, and it was considered an impurity. Ford used chromium, and that made the iron more wear resistant. That's why you can take apart an E7 TE block that's got 100,000 miles on it, and the bores still look pretty good. I mean, a lot of times you can still see a little bit of cross hatching. It's because the iron they used was very, very wear resistant. And you got to keep in mind, no manufacturer is going to make a super hard iron because they have to machine it. And if they increase machining costs, that cuts into their bottom line. They're not going to do that. They want it to be wear resistant, but they want to make it as cheap as possible to machine, and they want to make the iron as cheap as possible. You start adding a nickel and chromium, a bunch of chromium and all this other stuff, it just raises the cost of the iron for really no benefit in production stuff. The benefit of the Mexican block was the main caps. This is the main cap off of a Mexican 302. This is the main cap off an American 302. And it's pretty immediate and pretty obvious what the differences are. You can see how much more iron is in this. It's a stronger main cap. So I guess if I wanted to go racing, and that's all I was going to do with it, I might use a Mexican block, because it is softer and it is more crack resistant, just because the iron is a little bit softer, and you get better main caps. But if I was going to build an engine for a street car that I wanted to put 150, 200,000 miles on, I wouldn't use a Mexican block. I've taken apart a whole bunch of them, and every single one of them had a big old ring ridge at the top, and I've never seen that in American sourced blocks. Myth number 2. Don't put a stroker kit in a 289 block because the cylinder walls are shorter than a 302, and you'll wind up with the piston coming out of the bottom of the bore. False. but true. But we're only talking about a 1/10 of an inch difference in cylinder wall length. And it was the early 289 blocks. The later ones had the same length cylinder as the 302s. That 1/10 of an inch isn't going to make any difference whatsoever. The pistons are going to come out to the bottom of the bore a little bit anyway. And it's not going to, that 1/10 of an inch isn't going to cause a bunch of piston rock or anything. So I would have no concerns whatsoever with using a 289 block and building a 347. Here's one I've seen, I can't tell you how many times. Oh my God, my block has a hole in it. Should I be worried? That hole's supposed to be there. That's one of the oil drain backs. You have an oil drain back here, but you also have one here, and that directs oil towards the timing gear and to the distributor gear. A lot of times I'll clean these up and I'll actually lower the hole a little bit to allow a little more oil to get to the distributor gear into the timing set. And here's another good one. Years ago, I had a buddy of mine tell me, say, hey, I built a 351 for my car, I started it up and it doesn't have any oil pressure. I said, bring me the engine. Pulls it out of his car, we throw it in the back of my truck, I bring it home, pull the intake off. That plug was missing. That's the main oil galley plug. If that's not there, you're not going to have any oil pressure anywhere in the engine. The thing's going to be bleeding internally. So I put a plug in there and I staked it, put the engine back together, took it to him, and the thing ran awesome. Okay, there's the hole from the opposite side. And you can see how it was cast and how crude their cleanup was. They just kind of knocked some of the iron out. You can clean that up, like I said before, with a burr bit, and you can actually lower the hole a little bit to get a little bit more oil onto your timing set. But another trick is that plug right there. You can drill a small hole in the center of it and it'll direct pressurized oil onto your distributor gear, and consequently some of it will wind up on your timing set. That's just a little oiling mod trick. But be warned, if you drill that hole in that plug, it needs to be teeny tiny. And I'd have to look it up to see what size. That's like 15 thousandths or something. It's small. You don't want to make some massive hole. More is not better, because you're creating an internal pressure leak. So the more oil that's leaking out there is less oil that's getting to your mains and everywhere else where it needs to be. Myth number 3. Best cylinder heads to use are the early 289s because they've got a really small combustion chamber and you pick up a bunch of compression. Now this is my opinion. Yes, you're going to gain compression by going with a smaller combustion chamber, but you wind up with a smaller intake port and an exhaust port and smaller valves. And I'll go over to the bench and we'll look at a couple different cylinder heads. Okay, this is our 1970 351 Windsor head, and you can see the shape of the combustion chamber. And you see the valve sizes. I've already started porting these. And we'll keep going with it. I got some chamber cleanup to do. And I gotta get new guides and seats put in these. This is a 66. Actually, no, this is the weird E6 head. Sorry. This is the 66 289 cylinder head. And you can see the shape of the combustion chamber. You see how much smaller it is? Yes, you gain compression. But look how shrouded those valves are, because the combustion chamber is so closed in on them. You're losing a lot of flow just on this side of the valve. And look how shrouded that exhaust valve is compared to this. And port size and valve size are going to be different. This is an untouched, unported 351 Windsor. This is the 289. You can see a difference. And we could measure it, but you can physically see the difference in the two. And the exhaust ports are the same. Kind of the same scenario. These are smaller valves. So yes, more compression is good, but not at the expense of being able to get more air and fuel into the cylinder. So any benefit would be erased by the lack of flow. Crankshafts. 1-piece rear main seal, 2-piece rear main seal. The only difference is this. So if you wanted to take your crankshaft and get it turned, and you wanted to put it in a one-piece rear main seal block, all you'd have to tell them is to remove that. This diameter, it's the same as this diameter. It's a super simple operation. Now this part is my opinion. Myth number, what are we up to now? 27? You don't need to put any thread sealer on those in a Ford. Yeah, you do. That hole goes all the way through, into the engine. Right next to the rear main. These will leak oil. I promise you they will leak oil. I've seen it. When you have oil trace going down the flywheel away from those bolt holes, they will leak. Now a lot of guys will say, well, you know, that with the PCV system and everything, there should never be any pressure in the crankcase, so there was no reason for oil to get forced out of those. False. PCV valve goes bad, definitely have pressure in the crankcase. If you're running forced induction, you're definitely going to have pressure in the crankcase. Oil will leak out of those. It takes 2 seconds to put some thread sealer on them, even just Loctite. It'll eliminate the oil leak. I've actually taken cars apart to fix a rear main seal leak because everybody insisted that's what it was, and it wasn't. It was those bolts. Thread sealer. And you'll know if it's the bolts leaking, especially in a clutch car. If you have any oil whatsoever on your clutch disc, it isn't from the rear main seal. And I've taken cars apart where the clutch was soaked in oil. There's no way for oil to get from the opposite side of the flywheel all the way around it into the clutch. The only way it could have gotten there is through those bolts. But when they switched from two-piece rear main seal to one-piece rear main seal, that's also the exact same time they switched in the 289 or the 302 from 28 ounce to 50 ounce. So if you've got a crank like that, that's obviously a two-piece, it's 28. If you have one that's a one-piece, it's 50 ounce. That's really super easy. You can walk up to a crankshaft laying on a bench and you can tell exactly what it is. The older cranks are actually better. They're heavier, but they're stronger. There's more meat in them. So my idea, call me an idiot, is that block, that 302 block that I was showing, I think in the last episode maybe, the E7TE. I think I'm going to take a 289 crankshaft and have it cut for one-piece rear main seal, and I'm going to put it in that block, and I'm going to build a roller 289. And why would you do that? You're costing yourself 13 cubic inches. Well, why not? I mean, it'd be kind of cool. You know, why not put it in the 65 maybe and say, hey, that's got a 289 in it? Because it does. It's a roller 289. And it's way cheaper to put a factory-style roller camshaft in there with the factory roller lifters, dog bones, and spider. Way cheaper than the link bar stuff. And I never have to worry about a camshaft going bad. I mean, that factory shit will last a long time. Myth number 427. This is a good one. So you got these guys that'll say, I put a set of forged rods in my 302. Well, your 302 came from the factory with forged rods. I mean, all 302 rods were forged. Every single one of them. Now, they may not be as badass as a forged rod from Scat or any of the other companies, but they're still pretty damn good rods. They're pretty strong. The downside of the 302 connecting rod is the rod bolt. They were small. And if you drill it out for the bigger size, then you're losing meat in the connecting rod. So for that, yeah, it probably is better if you go ahead and buy an aftermarket rod with a bigger bolt in it because it has more meat in the big end to support the bigger bolt. Another one, what are we up to? Myth number 428. It's a waste of time to put a forged bottom end in a stock block 302. Yes and no. That forged crankshaft is stronger than the block. It's pointless. You might as well just stick with the stock stuff. Yes and no. Depends on what you're doing with it. Excuse me. So the problem with the Ford 302 is the crankcase was so small they couldn't make the crankshaft big enough for the counterweights to be large enough to offset the weight of the bob weight of the pistons and the rods. So they put weights on the flywheel and on the balancer. And the early ones were all 28 ounce. Well, around 1980, 81, somewhere in there, when they were switching from the 28 to the 50 ounce, when they went from the 2-piece to the 1-piece blocks, they took even more iron out of the crankshaft, and they took more iron out of the blocks and everything else to lighten everything up, because you got to cut costs. When they took the weight out of the crankshaft, they put even more weight on the flywheel and the balancer, and then it's 50 ounces of weight. That's a lot. You gotta remember, 16 ounces is a pound. So that's a lot of weight at the ends of the crankshaft. Now, if you're driving around in your stock car and you know, you might turn at 4,500 RPM, maybe 5,000 on a blast. But if you're wanting to turn this thing 7,000 and you're making a bunch of power and there's a bunch of harmonics in that crankshaft, think about all that weight that's getting slung around on the ends. That crankshaft is doing this in the engine. It's like a wet noodle from all that weight slinging around. And that's harmonics, and that's what destroys factory blocks. Now, the 28 ounce stuff wouldn't be as bad, wouldn't have as much movement, but you're still going to have movement. Now, you put a good forged crankshaft in there at 28, or even better yet, 0 ounce imbalance, make it internally balanced, your stock block's going to last a hell of a lot longer. But is it worth the cost? That's like buying an expensive aftermarket block and putting a super cheap cast steel crankshaft or something in it. You're still going to have this, and leaving it 28 or 50 ounce. And you could wind up destroying a really expensive aftermarket block. It's kind of either go all in or don't. That's my opinion. If you internally balanced a stock block deal, the block is going to be able to handle more because there's less harmonics happening inside of it. That's just my opinion. Take it for what it's worth. Myth number 429.9er. Manufacturers took cast iron out of the engines to cheapen them up. Yes and no. School of thought to this day is we got to improve fuel economy. The easiest way to improve fuel economy is to reduce weight. Reduce weight in the car, reduce weight in the engine, and things were no different in the 1970s into the 1980s. Same school of thought. We can save a couple bucks, and we can potentially pick up a few tenths of a mile of the gallon by cutting some weight out of this thing. Make the crankshaft lighter, make the block lighter, make the overall package lighter. And it'll help improve fuel economy. That's the truth. I mean, I've been around cars since, I kind of got lucky. When I was first getting into this thing, everything was still carbureted and they were going into fuel injection. So I got to learn both. And I've been in the field for years, and I'm up to date on all the current technology and trends in the industry because it's part of my job. I have to know. I have to know what kind of steels they're using in these things so I know repair processes, and I have to know. And they're doing everything they can. The aluminum F-150 is a prime example. They're doing everything they can to reduce weight. If you reduce weight, you gain miles to the gallon. So yes, they were saving money, but there was more than one purpose. And speaking of the use of aluminum, that's the prime example why the majority of engines are aluminum now. It's not just the fact that it dissipates heat faster. There's a lot of benefits to using aluminum, but it's also a heck of a lot lighter. Aluminum is more expensive than cast iron. If they could do the same thing with iron that they're doing with aluminum, you gotta bet, I would guarantee you my next paycheck, that they would still be using cast iron stuff. Otherwise, this is one of my favorites. Well, the early blocks are better because in the late 1970s they switched to a thin wall casting. hold on a minute. So in 1960, the Ford Falcon debuted as it was the first compact car offered by the big three. But for the first 2 years, the only way it was available was the little 6-cylinder. The people wanted V8s. So Ford set out to design a lightweight, thin wall casting V8. And the 221, 260, 289, 302 was born. It was always a thin wall, lightweight engine. They needed a compact package for a compact car. So the right way to say it would be a thinner wall casting, but they were always a lightweight engine. I think that's gonna do it. I got a bunch of stuff I gotta get done. I'm off for 2 weeks. If you guys watched my other video, I'm, I guess, sort of unemployed, but not really. I mean, I technically have 2 jobs, or my choice of 2 jobs. But I'm gonna get working. I got stuff I gotta do on the house, and I've been working on fitting the door on the 69, and I'm gonna video that. And maybe I'll put it out later on in the week. You guys get out in the shop and work on your projects. You guys have a great day, and I'll see you maybe in a couple days.